Okay, that should be about enough time. Let's get started. So today we're focusing on the web access logs with Elasticsearch and machine learning. In the past we've done webinars that have kind of demonstrated the features and functionality in detail of machine learning. And if you haven't seen those, I suggest you going up to Elastic's website and Googling around, looking at some of the videos. They're really great. Don't do it right now, because this is going to be a great webinar for everybody. Today's webinar is going to focus on a specific use case around web access logs. There's, especially around operational security reasons. A lot of reasons to look at web access logs. You can parallel this into a lot of other event log and analysis, but by giving you kind of this overview of web access log and how to utilize them within the Elastic Stack and machine learning, we're really trying to get kind of beginning to end, give you an idea of working through getting to a machine learning information. So actually, first let's start out with introductions. My name's Tom Grabowski. I'm the product manager for machine learning here at Elastic, and I'm joined today with Dr. Steve Dotson, our technical lead on machine learning, and the founder of PreAlert, the company that Elastic acquired last year that has evolved into the Elastic's machine learning feature. I'm going to start out by going over a few slides and then handing it over to Steve to provide a nice demo of going through the raw web access logs and showing operational security insights within the data using machine learning. We'll reserve some time at the end of the hour to answer questions. Now, just want to go through some housekeeping logistics and get those out of the way. The most asked question is, can I get the slides and recording? So, in a couple of days, if you've registered, which I assume everybody that's on this call is registered for the webinar, you will be receiving an email link with all the slides and recording information and be able to watch it again and be able to pull what information you have out of it. There's also a link for our IRC channel for Elastic webinars. That is the best place to start asking questions. You can ask questions through the webinar, and we will collect those questions and we'll reserve some time at the end to actually go through a Q&A session for answering some of the questions we see in that IRC. If you haven't already, please select high resolution on your YouTube video player for this. It doesn't matter as much for the slides, but once we get into the demo, the high resolution will help you view the demo much better. Now, just going to start out by giving you a brief intro into Elastic Stack for those that are a little unfamiliar. So you understand the framework for Steve's demo. At the core of Elastic Stack is Elasticsearch, of course. Our distributed RESTful search and analytics engine lets you search and store your unified metrics, logs, and data so you can correlate across them. At the bottom you see the Logstash and Beats, which make up our data collection and processing pipeline, and they put the data into Elasticsearch. And then on the top you see Kibana, which is our dashboard for management and user interface providing rich and robust data visualizations. All these components make up the Elastic Stack and are all open source. Elastic's commercial offering is called XPack, which extends and hardens the Elastic Stack, providing security such as user authentication and authorization, audit logging, and encryption. It lets you safeguard data down to the field level. XPack also includes alerting and monitoring with a rich graph visualization and API. And finally, machine learning, which Steve will cover in some detail with his demo. The demo is going to show you from going from raw data, collecting or ingesting that data and enriching it within Beats. Beats then inserts the data into our Elasticsearch cluster, and then the visualizations within Kibana and demonstrate some of those visualizations for analyzing and alerting on the data, with machine learning for operational and security insights. Now I'm going to hand it over to Steve to start the demo.
Great, thanks, Tom. I'll just start by showing my screen. And giving you an overview of what I'm going to do. The majority of what I'm going to do here is a demo. So I've got a couple of slides just to set up the scenario, and I'm going to focus mainly on machine learning. But before I get into machine learning, I want to talk a little bit about the FileBeat Nginx module, because one of the sort of strategic things we're doing to help you use the Elastic Stack and make more effective use of the Elastic Stack is to really go from raw data right through to alerting, as Tom said, and that involves ingesting, enriching, visualizing, and analyzing the data. So I'm going to basically give you a demo of the FileBeat Nginx module, and that will then lead into an introduction to machine learning and a demo of how we can analyze that data we've ingested. I'm then going to talk about how we're shrink wrapping machine learning jobs and shrink wrapping configurations to show you some best practice ways of using the machine learning component in Elasticsearch. And it'd be great to get feedback on those and which ones should we prioritize first. I'm also then going to, at the end, give you a sneak peek into some of the features we've got planned for 6.1 and actually give you a live demo of some of the forecasting features we've got. And then, as Tom said, finally, we can wrap up with a Q&A. So, first of all, Nginx FileBeat modules. So FileBeat is effectively a set of lightweight shippers that can take raw data and ship it to Elasticsearch. Elasticsearch can then enrich the data using the ingest pipeline or via Logstash as well, and then store the data for analysis and visualization purposes. So, typically this is an example of an Nginx log. The log format is in the top box there in terms of how the log format was how the log data was created, and then there's some example log lines below. So I'm now going to get a bit technical, and I think I'm going to keep it at a reasonable technical level as I go into this, and I'm going to go into how I actually do this in Elasticsearch and FileBeat. Okay, so here's the data that I'm going to be ingesting. As you can see, it's sort of the typical log files you get from Nginx, which includes access logs and error logs. And as you can see, the access logs contain things like the remote IP addresses, the timestamp, the URL, the response code, the user agent, etc., and the referrer, etc. And ideally, what we'd like to do is to ship this data to Elasticsearch. We may want to enrich it. So, for instance, if we can look up the geolocation of the IP address, that can provide us with additional insight into what's going on in the data and where we're receiving traffic, from, and also we can do things like parse the user agents to help summarize that information. Because as any of you who've worked with user agents, they typically can be quite varied and a bit ad hoc in some of the way that they're described. Okay, so if I've got data like this, I can simply create a FileBeat configuration file, and this is really based on the FileBeat.full.yaml file that we ship with. And really, here what I'm saying is, there's some data here that exists in these directories. Treat this data as Nginx access logs and treat this data as Nginx error logs. And that's pretty much it. And with this configuration, what I'm going to do is I'm going to run FileBeat with the setup command, and specifying effectively I'm going to get the output to standard out. The module I'm interested in is Nginx, and I'm going to run it with setup, which means that it's actually going to create ingest pipelines. It's going to create templates in Elasticsearch to allow us to understand the data with the correct mappings. It's also going to create dashboards for us to visualize the data in Elasticsearch as well. So in Elasticsearch at the moment, I've got effectively no file indexes, no templates, no ingest pipeline relating to FileBeat, etc., and no data there. Okay, so if I run this, effectively what this has done is it's started pushing data to Elasticsearch, and sorry, this is a sort of an example where the demo kings aren't very friendly to me. So what this is doing is it's passing data to Elasticsearch, and if you just give me a minute, we can then visualize this data. And so we can actually see, here are some of the Nginx logs that we've ingested, and what we've done is you can see that we've actually parsed those messages, those raw messages that were going in. We've actually used the ingest pipeline and the geo-IP extraction methods of the ingest pipeline to actually extract, create longitude, latitude on this. We've also parsed the user agent string and separated that into different functions. And what this allows us to do is also to visualize this data on dashboards, and ultimately we can also they report on this a lot more easily, and also, importantly, getting onto the meat of this talk, we can actually, run machine learning jobs based on the fields that we've specified there. So going back to the presentation, apologies for the slight hiccup on the ingest there. What I'm really going to focus on is the machine learning component, and really talk about that data that we've ingested using FileBeat and put into Elasticsearch and visualize, how we actually analyze that using machine learning and the value we can add to that using machine learning. So, first thing, and I've presented this slide before, several times, but machine learning is obviously a very sort of overloaded term that's used throughout the industry to describe lots of different technologies. And over time, sort of as part of the machine learning group at Elastic, we plan to cover more and more of these technologies to add more and more value to the data that you're putting into Elasticsearch. But initially, really our goal is to add value to the sort of the data that we see a lot of people putting into Elasticsearch, and that's logs and metrics. And Nginx logs are an example of log files, and really, when we're analyzing log data and metrics, it's mainly about time series analysis. And when we're analyzing time series, one of the key insights we can get is to show you when those time series change, and really, that's what's called anomaly detection in these time series. So sort of the main methods that we're applying currently are really unsupervised machine learning techniques that allow us to do time series anomaly detection on data. It's not as simple. It's not just looking at single metrics and identifying deviations. We can also create profiles of entities, temporal profiles of entities, and understand when that deviates as well. And I'm going to be going into examples, as Tom said, how we can use those unsupervised techniques as well to identify unusual things in the security space, etc. Okay, so really the key use cases for this technology are in the IT ops space. Typically, if you ingest a lot of data and a lot of data is going in, how do I know if my systems are behaving normally? And where do I set thresholds? If I can automatically create some type of baselines of all my metrics, I can potentially understand what's going on and find the root cause of problems very, very easily. And this is sort of like specifically one of the main areas I'm going to focus on in this demo. In addition to that, IT security. If I'm looking for unusual users, unusual actors, unusual processes that are running in my system, again, I want to use some type of behavioral analysis, some type of anomaly detection to detect that. And this is again, a set of use cases I'm going to be going into on your Nginx logs to show you how you can do that via some simple configurations. Okay, so now I'm going to get straight into the machine learning demo, and a lot of what I'm covering in this demo is actually the content of a blog that we recently wrote as well, but I'm going to be going into a bit more detail and actually hopefully doing this live for you as things work through. Okay, so going back to my window, effectively, what I'd like to do is analyze some of that Nginx data. And in machine learning, in the machine learning tab, you get when you install XPack, effectively there's ways of creating what we call jobs. And in terms of analyzing Nginx data, there's various ways of looking at it. But to start with, to start with, I'm going to start with very simple ways of doing this. And I normally recommend this is what we do, start with simple sort of key performance indicators for your system, which can generally be event rates, counts, key metrics, and so on, and then build out more complex use cases. I think understanding the value of how the product works and what the value it gives you on the simple metrics often allows you to build out more complex use cases as you become more mature with the product. Okay, so to start with, I'm going to start with a single metric job, which is really, the goal here is that we provide a very similar interface to the Cabana Visualize interface, and we're basically allowing you to draw a chart and then to analyze that chart, using our machine learning capabilities. And this should give you some sort of intro into the capabilities. So the first thing I'm going to look at is actually the distinct count of the IP addresses. Now, the reason I'm going to do this is sort of, this is one of the sort of like the bottom line metrics for a website, is that, for instance, if the typical number of visitors drops significantly at some point, it often indicates there's an application problem. As one of the goals is to bring more users to your website, if that suddenly drops because of an operational issue, that's something that your operations team needs to be aware of, and something that is often important. So in this case, I'm looking at over time the distinct count of IP addresses. I've got this is running on my laptop, so I've got over 14.5 million records in my Nginx logs here, and it's anonymized data from a website, so we've rendered that very quickly. And now what I'm going to do is create a job. I'm going to call it visitor counter, visit count. And when I create job here, what's going to happen is we're going to go off, we're going to query Elasticsearch, and this is all being done by the ML plugin, which is embedded in Elasticsearch. We're then going to effectively stream the data from Elasticsearch through the machine learning component in Elasticsearch, and then effectively calculate the probability of the current occurrence based on what we've seen historically, and create anomalies as we see them across the screen. And hopefully this will give you a good demonstration of what's going on behind the scenes. And if Google Hangout lets me run something effectively, here we go. Okay, so what you can see there is the blue shaded line is effectively a visual representation of our models as the data is being streamed through our analysis engine, and the sort of the DNA lines or the swim lane lines that are drawn across there are indicators of anomalies. I think this, I know I've presented similar things before, but this again sort of shows, in a bit more detail how our models evolve as we see the data. So, on the left-hand side there, I didn't put any configuration in to say the data was periodic, or what type of bounds it was, or what type of distribution I wanted to model the data with, etc. And as you can see from the left-hand side there, we gradually learn. Initially, the bounds start tightening a little bit in terms of our model, and then we start learning daily periodicity, and then as time goes on, we actually then learn weekly periodicity, and we end up with actually a pretty tight baseline around the data in terms of modeling this particular metric. And by modeling this accurately, we can actually detect things like these intraday drops, which are often quite hard to detect by thresholds. And if you see what the product does down the bottom here, we can actually see that here we've detected that typically we expect 4,000 visitors, and we've only got 600 at this particular point in time. And so, this is sort of a classic example where, we've run anomaly detection, we've created an anomaly, and what we can do in the product is actually run this on an ongoing basis, on a continual basis, and we can also create a watch to alert when we get anomalies. And that really, sort of can bring this from being a historical forensic tool to something that you can run in real time operationally as data is being streamed through. Okay, so one of the challenges, and as I said, as Tom mentioned, we started building this technology sort of back in 2010. One of the challenges is making this technology accessible to as many users as we can, and making this technology simple for people to use. And part of that is really part of that is making simple interfaces like this single metric viewer, but it's also for us to share our learnings, our best practice, our domain knowledge with you in terms of what type of configurations make sense. And really that's what we've done here. And the rest of the jobs that I'm going to be presenting here are jobs that I've actually sort of pre-run, just to make the demo easier. And these are jobs that sort of like represent some of the best practice or the things that we've found to be effective on the various customer data sets we've run this across. We've run this across. So the first set of analysis I'm going to be talking about are the operational usage, where you're looking for sort of unusual operational issues, such as something wrong with your Nginx processes or your content delivery system, etc. And in those cases, we've got a couple of things that we're looking at. Like, one is potentially this unusual visitor rate, which we can do by simply looking at effectively, this is the distinct count of remote IPs. We can also look at, well, is the overall rate of Nginx requests changing or dropping significantly? And again, that's something we can do very simply by just looking at the count of messages. And what we can do, in an operational sense, is we can present these on a dashboard, and we can cross-correlate across these and present the results together. And so, effectively, what this is showing is overall, how is my Nginx, how is my website behaving? According to the data that we can get back from the Nginx logs. And at this point, we say we've got an anomaly. And what this is saying is that there's an anomaly in two variables here. One, the overall visitor rate drops significantly, and the other, there's actually a low request rate in terms of the total number of requests drops as well. And that's great, and that's sort of like a nice high-level metric, and that's maybe one of the type of metrics you might have in your operations center. But really, what you often want to do is work out, well, what's the root cause of this? Why is this happening? And that can bring into play some more complex jobs that we can create, and really sort of where the power of this technique moves beyond single metrics into multiple metrics and potentially population analysis. Okay, so what I'm going to do is just show, as well as single metric jobs, we can do multiple metric jobs, and then I'm going to basically specify a multiple metric job that we can create for this Nginx data. So if we're looking at event rate, we can look at the overall event rate, but we can also look at the event rate split by a particular field. So we could look at it, potentially split by. You'll see how the new UI in 6 helps this process in terms of selection as well. But here, as you saw this split, I've actually split the data by method there. So we could actually run, independently baselines for all of these all these different series, and looking at whether there was a sort of unusual volume of posts compared to gets, etc. And we actually can perform this analysis in a multivariate sense as well when we do that. And that can give you a deeper insight into some of the things that are going on there. And also, something that I missed off at the bottom here is when you create a job, you can specify run this in real time, and potentially also create a watch on that. But because I've got 14.5 million records here, I'm actually going to show you a result of an analysis that I did prior to this call, and that's looking at effectively unusual response code rates. So in this case, I've actually done a slightly different configuration where I'm looking at the count of the different response codes. So you can imagine that really there I'm looking at overall, are the number of 404s changing? Are the number of 200s changes? Are the number of 500s changing? And to give you a more granular insight into changes in the event rate of your Nginx data. Okay, so drilling into this data, we can see sort of straight away there's a nice visual of the different response codes and the anomalies across those different response codes. And straight away you can see that there seems to be some unusual things happening. Sort of around this time, there seems to be like there's someone who's retrieving a lot of 404s and so on, and some other things later on. But often what we're providing here is a general purpose dashboard. Our Anomalies Explorer here is really sort of a general purpose dashboard for displaying the many different types of jobs that we can provide. And one thing we'd like to do is, as well as providing sort of good practice dashboards in terms of good practice configurations in terms of jobs, actually sort of go through the whole process with you and actually provide visualizations that back this up and ultimately potentially some workflow describing what's going on. So we've actually also shrink wrapped, as well as the job, we've shrink wrapped dashboards up on this. So when I click on this link here, we can go to something that we call the Count Explorer that can actually explain the context of this result in a bit more detail. So what we're seeing here is sort of this is a general dashboard zoomed in at that time, focused on 404s, and with that we can get a better idea about what's going on in terms of the data. So first of all, we obviously see this high count of response codes that are 404s, and we see that they're all 404s. We also see that there's one particular IP address that's dominating this, and we can then interact with this dashboard and filter on this and sort of explore the data further. And when I do that, I can then start seeing effectively that this is sort of the URL that this is the particular URL that they're hitting in this case, and then we can see other contexts like the user agent, and we can even go from here straight to the raw data and actually see the raw records associated with this particular user agent at this particular time, and so on. So there really I've gone straight away from sort of our analysis straight down to the raw data and some context behind what we're doing. And the good thing is that we can actually sort of again correlate and overlay this with other types of analysis. So here I've got the sort of operational analysis I provided before, plus this new job which analyzes response codes, and we can see that at this point in time there's a set of unusual things happening. And clicking on sort of overall, can you give me a holistic view into what's going on at this particular point in time? This shows you that the visitor rate's dropping. There's a low rate of requests. The 404s increasing significantly at that point. The 301s 301s drop, and the 200s drop at this particular point. And this is sort of like out of all those 14 million records, we've pulled together this set of things to say, well, this is something unusual that's happening in the data, and here's sort of some context behind it. And, in fact, what happened here is there were actually some configuration changes to the content management system that actually caused an interrupt on the site, and then actually when the system was brought up, it actually then subsequently introduced a load of 404 errors into the system. But the problem was the operator didn't have visibility into that until sort of later on in some subsequent reporting. And with this tool, we can actually perform this analysis on an ongoing rate. We can then create these anomalies as the data is being streamed in, and present them to the user in this type of nice context. Okay, so that's like the first part of the demo, which is really going into an operational use case where we can take some of the event rates of Nginx logs to try and help us understand operationally what's going on our website. But something that's also quite important is looking at sort of unusual clients. Now, the thing is, as any of you who manage websites, you realise there's often a lot of bots, there's a lot of malicious activity built in with those normal users, and I think often it is useful to understand what who's doing that, what's the proportion of the clients are doing this, and also potentially you can filter your analytics by excluding these outliers from the analytics, which can give you a lot better understanding of what the normal usage of your website is compared to what bots are doing when they're crawling the website. Okay, so in terms of population analytics here, really, what we're doing is we're looking at the features of an entity. In this case, an entity is a client, and we're looking for outliers in this population. So the type of things we may want to look at are like the rate of your the rate in terms of the number of URLs they're hitting, or the distinct count of the URLs they're hitting, or just basically their overall event rate. Those type of things in terms of the features that describe a client's behavior are things that we may want to look at, and create a model based on that, and then calculate the probability of what someone's doing based on that model. So this is a really messy graph. I displayed it, drew it before, but it actually sort of shows some of the complexity you have when you try and sort of draw some of this stuff out yourself. And really what we're trying to show here is on the left-hand side here, we're showing the distinct count of URLs for IP addresses, for a selection of IP addresses. So you can, which is really sort of indicative of bots or scanners across your site. And you can see that there's a large proportion of the users are normal, and then some who are behaving slightly differently. And then, but is that how different is that, and is that something that's worth you paying attention to? And then we've got sort of on the other side, we've just got like heavy hitters, and potentially in the worst case here, this could be some type of denial of service against your site. But in this case, we're really looking for like high counts of messages for particular remote IPs. And these are the type of features that we can build into our population analysis, and we can automatically run this and surface these results for you. Okay, so I can actually go into the data now, and the jobs that we've created here, there's two jobs. One where we're effectively looking at where we're looking at a high distinct count of URLs, and the other where we're looking at high rates. Now, these jobs require what we call the advanced configuration panel. But hopefully with the documentation we provided, these shrink-backed examples, etc., they should be fairly straightforward to perform. I mean, really, what we're saying is a high distinct count of URLs over, which is a keyword defining a population analysis, remote IP addresses. Okay, so let's drill into the results of this. So straight away, we can see sort of there's an overall timeline which indicates there's a fair amount of unusual activity happening in terms of these type of populations. But we're also listing sort of the top 10 unusual actors at this point in time. So if we sort of drill into a specific one of these, we can see a bit more detail about what's going on here, and we can see that at this time, typically, a typical user in this short time period hits a couple of URLs, and in this short time period, this particular IP address is hitting 12,000 URLs. And again, we've also provided some dashboards specific to this. And I can drill into this in terms of the URL Explorer, which is similar to the Count Explorer, and we can see that here's the example. Here's the profile of response codes, status messages this client was returned, and the majority are 404s. And below here we can see some of the messages that they were trying to effectively, the URLs they were trying to hit on the site. And as you can see, potentially some of this is associated with cross-site scripting, etc. In terms of trying to understand what's going, trying to be malicious against your site. So you can see there that by just looking at the population, by looking at the people that are unusual in that population, we can pull out, this type of actor in that space, and automatically sort of give you some workflow in terms of investigating that. Now, another sort of key thing is that the data that I'm presenting here is all in Elasticsearch. So the results that we write, the anomalies that we create, and all, everything you see here is in Elasticsearch. And so we can create additional dashboards behind this. We can actually create automatically report on the different segments of users that we're seeing based on these characteristics, and we can effectively use it like we can in any Elasticsearch search report or any Elasticsearch search query. Okay, so that's a very sort of quick intro into some of the security analytics, and the population analysis. But what I'd like to do is really talk a little bit about this shrink wrapping use case, and this is also going to sort of touch on potentially some of the future work we're going to do. So sort of as I showed before, or as I tried to show before, if I go to the page. Okay, as I showed before, I mean, effectively, when you start FileBeat with the dash setup command, you get a number of things. You get an ingest pipeline, which allows you to parse it and enrich the data. But you also get, this is the FileBeat dashboard that you get with FileBeat out of the box when you run dash setup. And my previous demo, I should have just waited because the data has actually gone in fine. So when you run FileBeat, and the whole demo I did initially, when you take the data, you run it with dash setup, you get the ingest pipeline and these dashboards, etc. But now in 5.6, you also get a set of machine learning jobs out of the box, and these are the machine learning jobs that I specified. So if you're starting from scratch and you haven't ingested Nginx data yet, you can run it with the dash setup command, and you get these jobs pre-configured, and these are things you can then effectively start using this, and that will actually continually run the analysis. It will historically pull the analysis and then continually run that on an ongoing basis. But what I wanted to show you as well is that not always, you haven't, often when we go into to customers, they have Nginx data in there already, or they have some other data types in there already. So we also want to try and package up jobs based on that, and I'll give you a sort of a quick preview of our 6.1 product and some of the capabilities we're putting into that to help you provide, to help you create these configurations and get the best value out of the product. Okay, so here is our sort of preview of our 6.1 product, and as you can see, the colors are slightly different due to accessibility, and also, hopefully when I go through this, you'll also see some of the controls are a lot nicer as well. Now, what I can do is when I create a job, okay, when okay, so what I can do is when I can go to this, we've got this component called the data visualizer, which is, so when you're creating a job, you can effectively go to the data, and we can identify, automatically that data is recognized to be Nginx. So in this case, we've recognized the data to be Nginx, and we've also presented sort of a high-level summary of the data. So actually, moving forward, we're then going to, we're planning to sort of allow you to run jobs directly, or actually understand data directly from this, or potentially even clean data based on this. But here's sort of like a summary of the data, and importantly, we've identified this as data that we can run Nginx jobs against. So I can then click on this, and this then allows me to to create Nginx jobs based on the fact that we've recognized the data. And not only does it create Nginx jobs, but it also installs some dashboards and some visualizations, etc. So when I create this, what's going on? What's going on here is we're effectively just loading the configurations, creating the jobs behind the scenes in our 6 products here, and I'm not actually going to be running the jobs here. I'm actually just going to be loading them, loading them up, and then using them for a further part of the demo. Okay, so that's running. The CPU seems to be a bit hogged on my machine, but while that's running, I'll start getting into another feature, because really what that results in is those jobs being created. They're based on the fact that we've recognized the data. Okay, so what I'm going to do now is just give you if things work is actually give you a brief hint of the forecasting that we've got planned in the 6.1 release. Okay, so I'm going to create a single metric job, just like I create any single metric jobs. Okay, I think next time I do this, I'll do this on the cloud, because my server seems to be holding up here. Apologies for the delay. So just while Cabana's loading, what we're doing here is we're taking data. I'm creating a job. So in this case, I'm going to be looking at mean of a particular value. And in this example, I'm going to be trying to forecast this data. So currently the analysis that you have is focused on anomaly detection. But what we found is that actually we can use similar models that we're creating to actually extrapolate the data, to actually show you where the data is going to go in the next week or so. So an example of that would be if I have 1,000 servers and I'm looking at the disks on those servers, can you tell me when the disk utilization is likely to exceed 100%? And those type of capacity management operational use cases are the ones that we're targeting with this capability. And the first release is going to show a bit of that, and we're going to add to it in subsequent releases. So first of all, I just create a normal job. So this is a normal anomaly detection job that we've run before. As you can see, we've identified some of the unusual spikes in this data. Then when I view results, I've now got a new button which says forecast. And when I click on that, this allows me to effectively enter a period like how far into the future do you want to forecast this data, and run this against the model. And as you can see there, I know this looks like a fairly trivial example, because we're taking the data and we're extrapolating it, but we're actually using some of our complex modeling techniques here to do this. So for instance, we're actually using the fact that we've got these long-term trends built into alongside the seasonal trends that we've got built into our models, and this allows us to extrapolate, and this allows you to see potentially where this value is going to be with a certain confidence interval in the future. And you'll also see that effectively the variance of the forecast increases as we go further into the future. And as we go further into the future, we become more uncertain, and hence that's going to grow. Okay, so what I'm going to do now as well is just run a similar analysis, but this time I'm going to run a similar analysis on the Nginx data. So this time I'm going to use distinct count, and as you can see, the drop down here is an improvement, because I can effectively get to remote IP pretty quickly. And what I'm going to do is just sort of extrapolate so I can see sort of like where the count of visitors is going to go moving forward. So again, we're running the same analysis, but this time with this sort of a version of the 6.1 product, and we're looking at the distinct count of visitors. And as the data goes across, we'll see, we detect a similar anomaly to the one we did before. And now when we view results, we can forecast, and we can sort of say, well, where's this going to go a couple of weeks into the future? And here, we can see that this is sort of like where we're predicting it goes, which, this is a pretty predictable pattern, based on this particular site. But, if there is a long-term trend, then this will allow you to sort of understand potentially with what capacity you need, sort of next Wednesday in terms of being able to look at your site. Okay, so sort of that's sort of a quick demo. Apologies for some of the red screens and not everything working as easily as possible. I'll try and do this again next time on the cloud rather than running this on my laptop. But now I'd like to hand it back to Tom, and we're more than happy to answer any questions you have on the product.
Thanks, Steve. Just to reiterate, though, the Elasticsearch, our annual conference in San Francisco, is coming up. The registration, I hear it just opened today, but you can go to the Elasticon updates page to get more information, or just like I said, the registration page is available. And we're going to take some 10 minutes to go through some questions. I've got some questions here that I've been collecting. One of the big questions that was getting discussed in IRC was, as far as the ingest of the data, you didn't use Logstash at all, right, Steve? That was just through the Beats Nginx module.
That's right. In this particular case, the FileBeat modules by default installed an ingest node pipeline. There's no reason why you can't do a lot of this through Logstash as well, and it really just depends on the customer. We've seen customers do both. That's just the default sort of way that FileBeat has shrink wrapped this particular ingestion and enrichment. And
the actual machine learning jobs were part of that module that got installed.
That's right. So there's when you run the Dash setup, you also get these sort of best practice machine learning modules for Nginx installed as well as jobs. And as I said, there's sort of like we're planning two ways for you to get your hands on those configurations. One via FileBeat setup, and the other via this data recognizer that's coming in 6.1.
And as far as what's open source and what's part of the subscription question.
Sure. Yeah. So the machine learning is part of XPack. So the machine learning specific features are part of XPack, and so they're the commercial features. All the FileBeat features we demoed here are open source.
The one question was coming up about, are we using probability algorithms on how to take holidays? How do holidays affect the probability?
Sure, good question. Yeah, so the whole process is we sort of have this Bayesian process that creates these these automatically learns these trends and automatically learns these complex sort of parametric distributions that we overlay on the trends, and we use those to calculate the probability of the current occurrence based on what we've seen historically. So that's the basis of the whole process. And holidays do come up as anomalies. If for instance, if you have if typically like on Christmas Day, you may not get as many website visitors, then potentially that will be an anomaly. But the way that we manage those through sort of winterization and other techniques is that generally operationally they don't affect your system as much as you may think first of all. If you do know this particular days that you're interested in, there's other ways of managing the models around that and managing the system around that. At the moment, that's only available through the APIs, but we're planning to build that out through the UI as well.
Great. As far as let's see, most of it was historical data. They wondered about being able to set up watches.
Yeah, absolutely. Yeah, I mean, I had enough trouble running a load of historical data, but it would have been really good to have this running on a live system, because we are, as I said, we can basically, when you set up that job, you can say just keep running it in real time indefinitely, and when we do that, the anomalies get written as documents back to Elasticsearch, and you can then set up watchers to alert on those or perform other actions on those. And that's sort of the primary use case. And we've actually, I sort of, unfortunately, I didn't quite show you it as I skipped through it, but there is a button on our job configuration page which shows you, which tells you, do you want to create a watch based on this as you roll it out in real time.
Great. Question about running Elastic Stack with machine learning as managed service. I would point to Elastic Cloud. Right now, machine learning is not a feature in Elastic Cloud. It's actually where we've just started going into beta with certain customers on running machine learning in Elastic Cloud. If you're interested, you should contact your Elastic account team to express your interest in running in Elastic Cloud. It will be we expect in the next few months to start rolling it out within Elastic Cloud to those subscription users. And also rolling it out to Elastic Cloud Enterprise as a feature. Let's see, another question. Where are machine learning jobs executed?
Yeah, good question. So the machine learning component is actually a plugin into Elasticsearch. So the machine learning jobs get executed on Elasticsearch nodes. You can configure which Elasticsearch nodes you want to run that on. It really, I mean, again, that sort of depends on your setup. Often customers with sort of like really hot data nodes tend to deploy additional nodes to run machine learning on specifically, with potentially slightly different hardware characteristics as well. But the machine learning jobs run on Elasticsearch nodes.
All right. Their questions are coming in fast and furious. So if I don't get to your questions, we'll stay on after this webinar and stay on the actual IRC to answer questions. If we don't get to your questions, or if for some reason I've missed your question, there is the discuss forums on Elastic's website, and specifically machine learning. If you're going to ask machine learning related questions, the best place to do that is through the XPack group within the discuss forums on the Elastic site. Let's see. Does machine learning have a REST endpoint that you can throw time series data at?
Yes, it does. It does. The entire machine learning, creation of jobs, pushing data through, viewing results, etc., is available via REST endpoints, and that's all documented on our website.
Great. Again, maybe I should just wrap up the questions right now. I think I've fallen behind on the webinars. I appreciate some of the Elastic guys that are on the IRC answering questions as well. So I think a lot of them have been answered. We'll stay on the IRC for to continue to answer questions for a little while. But I think that is a wrap for this webinar. Appreciate everybody getting on, listening to the webinar. It's been great. We expect to do more around, specific use cases in the future, specific applications. We want to hear more from you. So if you're on the IRC, please let us know what type of applications are you trying to use with machine learning. Nginx was our first, start to finish kind of module, with machine learning included. We expect to be doing more, especially with the data recognizer. So it'd be great to hear what types of application or common applications are you looking for. Thanks again, Steve. Great job.
Yeah, thanks guys, and thanks everyone for listening.